So the plan for today is to solve some ABC problems. I didn't stream for a few months, so there are a lot of ABC contests I didn't solve. So let's try to catch up some. The plan is to solve as many ABC problems as possible until the football starts. Yep. So we have football in 2 hours, so we'll have like 2 hours. Voice is not loud. Let's fix this. Let's fix the audio. I need to do this. Like this. Oh, now it's loud enough. Oh, nice. Даня, я за Англию болею, конечно. Как можно не болеть за Англию? Any of you has experience? Want to share? I don't have any specific experience. I'm just trying to solve some problems. So the way I usually do it in these streams is to open problem and to solve it without local testing. So I will open the problem and try to solve it without any local testing. And if I solve all the problems of the contest without local testing, it's a win. So it's like a fun game I try to play when it's just a small workout. Let's try. Why don't you write science? Because I'm too lazy. I don't know. Is it really that important? I'm not sure. I'm trying to keep this template as small as possible. So at some point, if I have time limit, I might try to add some hardcore optimizations like this, but usually it doesn't matter. Whew. Go. So sure, two types of content ABC RC. Because this company holds two types of content, ABC, but vice versa. Given a string represents type to the contest last week, for the next week. So if it's ABC, we should output ARC. If it's ABC, why not? If S equals to ABC, C, we output ARC. I forgot how to do it. Else out ABC like this. Right. Yeah, looks fine. Ooh, okay. First problem is done. How to open like this. Okay, kinds of snacks. Only snacks. Yeah, it's complicated. So we have N snooks and K kind of snacks. And we know, so we have like matrix. Okay, minus for each snook. Walk around, don't have mischief. Snooks have no snacks. How many snooks? What? Snooks who have no snacks. How many? So we need to find number of rows. What? So for each snack, we know which snooks have this snack. And we need to find snooks which do not have any snacks. So we have these snacks here and these snacks here, and we need to find. Okay, why not? arrays or sets. So let's make some simple arrays. So we have n and k, input n, input k. Now let's make Boolean array of size n, like this. Yeah, why not? Now we iterate all snacks. Read this d. Iterate all like this. Read this. And now we just make this ax minus 1 equal to true. Simply mark everything we see. Yes, now we need to calculate the result. So if we didn't see this snook, then we increase s like this. Yeah, looks fine. Don't try to think, just submit. Testing system will test it, right? Ooh, okay. I still can solve simple tasks. The elevation of ops I is h. Okay. And m roads, each connecting two different observers. So we have graph, okay. So we have n vertices and m edges. And this connects these two vertices, okay. So to be good, and this elevation is higher than those, all observatories can be reached from using just one road. Okay. It's also good when also you can reach performance using one road. How many good observatories? Higher means strictly higher. Yes, I think it means strictly higher, right? Ultramarine consistent with integers. Determined, so there's a height, so based on I retrieve 2, 3, 2, 4. And 2 observatories. So let's say 3 and 4. Preparing for next lockout. Yeah, will be next lockout tournament. I didn't see the. Do they plan to run another lockout tournament? I will take. I will participate if it's possible. It was fun last time. So we have. No, that's just a workout I do when I have some spare time. Too many places. And now we need to read this graph. So this is how I usually write the graphs. My fingers forgot how to do it. So it's from home to answer like this. And now put these edges into these lists. That's all. And now we just calculate the result and 0 for so if our height is less or equal than this height, then it's false. Yeah. Yeah, looks fine. Will it say this type to bring more luck in the future? I don't know. I plan to leave the city again next Monday, so maybe this week we'll have more streams than usual, but who knows. Give a pair of integers such... Oh, that's something mathematical. Okay. Give a pair of integers such that if I find equal to x, it's guaranteed there exists such pair of integers. Give a pair of integers. So I know the number x, and I need to give two numbers a and b, such that this difference is x. Can I just iterate as number a? So this difference, so even if you give two consecutive numbers, this difference will grow very fast. So if you look on number, let me see. We have a long. And I have this long defined as long. Just because I moved from Java. So if I just iterate from let's make like this. So if I know number a, then b. So the plan was like this. So let's say a5 equal to a power 5, like this. Will I get this integer overflow here? I think not. No, I will not have integer overflow here. So it's 5 minus x, right? It's b. So if this b5 is less than... should they be positive integers or just integers? Yeah, they may be negative integers. We may have negative integer here. Is it bad or is it good? I think it's fine. It's still fine. So if it is negative, we'll find. So okay. So we know b power 5, and we need to find b, right? How to find b? We need to take. Can I do it like this? Don't like this. I don't like this at all. Okay, why not? So we have approximate value of this root, and now let's find the good value. Like this. It's not very best way to do it, but should be good enough. Good enough. So now if it is equal to, and we found result. Yep. I don't like this line at all. Yeah, but I think it still works. No, it does not. So it's not working as a sample. That's sad. So it's not working on the sample. It's freeze. So it's 2. It's 32 plus 1. Why it's not working? So we have this, we have 32. Here we have 32 minus 33, we have minus 1. We have minus 1. Is it working for negative numbers or not? I'm not sure if this power function works for. If this power function works for negative numbers, it may not. Does it like this? Not the best code in the world, but let's try this. B equal where? B, oh my god. That was unnecessary. Okay. Okay, so we failed this contest, but let's try to finish it. So what is expected way to solve this problem? No editorial. Well, no, sorry. What did they expect? PX. Do they have English? Oh, they have English. Consider this sequence increasing to remember the elements of well, first time alpha experience, more of consider increase by well, it's sufficient only consider range from. So either okay. When A is fixed, and increase basic increase with method shattles versus boring. This time there is plenty execution to need to do so. So where's your solution? So you can iterate all values of A from in this range and all values of B in this range, and just check all possible pairs. Yep. Makes sense, makes sense. So we little bit overcomplicated stuff, but it happens. Still get accepted. Okay, but this is one of the tricks I learned when you need to calculate the root of some number. You can just calculate the approximate value of this root and then just find the good value using these simple loops. It's working. It's not the best way to calculate the root, but it's good enough. It's fast and it will find you the good value. So this power will usually you get about the good number plus or minus 1. So these whiles make at most like 1 or 2 iterations, and then we just check. Okay, let's solve all remaining problems. The paper can provide this stolen secret maybe can happens. And attend this in the party and that room contain numbers from 1 to n the height of the context. Before I had no pair of densities, find the condition below the plus difference of the tens number equal to sum of the heights. So it's way to choose 2 from the penalties, make a pair among them. How many satisfy the condition above? Okay. Difference of the numbers is equal to the sum of the heights. Okay, let's use paper. I prepared the paper. Let's write this down. So what I want us to calculate, I want file calculated pairs such that difference of their independent numbers, so it's like hi minus hj, should be equal to sum of sum of heights should be equal to difference of the numbers, so it's j minus I, right? So again, each time you have an equation like this, you want to put everything connecting to I in one part of this equation, everything connected to j in another part of this equation. So I'll simply move this I here, so it will be hi plus I should be equal to j minus hj. Oops. That's all. And now I can iterate or I find this value, and now I need to find all other what is it? So j is the maximum. So if I go from left to right, yes, I can iterate all j, and for each j I need to find number of such i's that this sum equals to this difference. So I'll make loop over this value of j, and for each value of j I will find the number of these i's. That's the plan. Boom, 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 boom. Boom, 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 boom. Good morning, you have morning right now. It's late evening in Russia. Where are you from? It's A, not H. Okay. You got the point. And now I'll simply iterate all values from 0 to n plus. I'll just put them in the map. This map will calculate the number of i's I see before with the given sum. Call it B. So now when I see next element of the array, I will put this value I plus A of I to this array B. And I will increase the result. I forgot to write n. Thanks so much. That's the most common problem. Yeah. Now I will increase the result by the number of elements with value I minus AI. Yep. Looks fine. Nice. And the final problem. No, not the final. Final, yeah. There's a game that involves three variables, not A, B, and C. The game proceeds. A, B, you must add 1 to A or B, then what? And then subtract B. So increase one value by one and then decrease another value. Okay. If it is AC, add BC. Okay. Okay. So given two variables, we need to add one to one variable and subtract one from another variable. Okay. After each choice, none of them should be negative. And it's possible to make n choice under this condition. If it is possible, also give one such way to make the choices. So, now, if all variables are at least 2, we can always do it. Right? Right. So if all variables are at least 2, we can always just make one operation, then make the reverse operation. So after 2 operations, we have the reverse one. So we have problem only when we have variables less than 2. Again, let me get my paper. So again, you have these variables A, B, and C, right? If they all are at least 2, you can do the following. When you call A, B, you make plus minus, and in the next operation you get minus and plus. So after these 2 operations, both values remain the same. And you do it for all of these pairs. So they always be non-negative. What if we have zeros or ones? Now it's more complicated. So if we have one small variable, so if, for example, A equals to 0 and B and C are big, at least 2, can we do something about this? So we can do it for operations A, B. So if we have A, B or AC, we make plus minus and then minus plus. So then A will not be non-negative, and here we have plus minus minus plus. So A will not be negative at any point. Yeah, it's still fine. This looks overcomplicated. If we have 2 zeros, we have A, B, C, and we have 0 here, 0 here, and something here. Now that's tricky. So sometimes we can, sometimes we don't. For example, here if we have like BC, we make plus minus, and here now we have 1, and now we can run AB, right? So I should give the... Ooh. Okay. Can I just make a simple dynamic programming? Just, yeah. I think the number, if the number is greater than 2, we can just say it is equal to 2. No? Because we will never need a number more than 2. So we can only think for each variable we can only consider values 0, 1, and 2. And now we'll have for each variable we have only values 0, 1, and 2. We'll have only 27 possible. Is it true or not? Let's say 5. 5 is 5 is totally enough. So we will never have variable more than 6. Yes, more than 6 I can prove, but so each value shouldn't be more than 6 at any point. So for each value we have only 7 possible values. So streams has ended. Why? Why it's ended? Fixed. Yeah. Let's do it like this. No, we have 5, so maybe it's too much. So if I have 7 variables, so it's 7 power 3. No, it's still enough. Yeah, it should be fine. Yeah, it still should be fine, right? 7 power 5 multiplied by 7 power 3. Yeah, it should be fine. Should be fine. Let's do it. So again, what's the plan? The plan is to have some max value. Let's say it's 6. So I claim that you never need a value more than 6. So I will say A's minimum is A and maximum. Screen is not visible. Oh, that's common problem. Okay, and now I'll simply make a dynamic programming, right? Right. No, is it too much? It 7 is too much, right? Let me calculate. So it's 7 power 3 is 330. So it's like this. So it's 300 multiplied 10 power 5. It's 3 10 power 7. Have a gigabyte of memory. Should be fine. Should be fine. Maybe 6 is too much. Let's say 3. I have no idea what I'm doing. Now we need a vector boolean. Do it like this. Don't like this. I don't like this at all. Let's do it in a simple way. Not the best code style, not the best code style, but it should work. Which problem is this? This problem. It's right here. Oh. Let me try. Should be fine. That should be fine. So let's say D0 ABC equal to true for it's not the best code style. Yes, I'm reusing the same variables because I can. Okay. Okay, now we're standing in this state. So this is the current state of our dynamic programming. We need to move to the next state. Hate this, I hate this. Okay, so I'll do it in a simple way. I'll just do it like this because I'm a lazy person. So if I have a b, so I move to state a plus 1 b minus 1, or to state a minus 1 and b plus 1. So if a greater than 0, then I can move to state I plus 1, a minus 1, b plus 1, c, like this. No, not like this. You move this from this and max. And I will just copy paste this 6 times. I hate this code. You should never copy paste code like this. Link? What link? What link? What link do I need? Link to the contest. It's at code begin contest 166, like here. If you can't find this link to the contest 166, it's... Well, I need to... in the end, I need to... Oh, I hate this. I hate this so much. So I need to output the sequence in the end. So I need to remember the previous state. Do I have enough memory? Should be enough. Should be enough. This is the last problem of this contest. What is the simplest way to do it? What is the simplest way to do it? No idea, actually. I hate this contest so much. Okay. Okay, let's just... I don't want to spend 3 variables on this, so I will encode my state into variable x. It's al multiplied by max plus 1 plus b plus c. So I just encoded my current state here, so I put my current state here. I simply hate this code. Solve some trouble, have some fun, yeah, like that. No, the last problem from ABC, sometimes it's complicated, sometimes it's not. So I just don't like this particular problem from. So usually there's some interesting problem in the last problem. maybe I overcomplicate things. Maybe it can be solved much easier than I'm doing. Maybe it's my problem. C minus 1. Here is BC. I will miss something in this code eventually. B plus 1, C minus 1. Okay, this is not the worst code I've seen in my life. But I hate it so much. Okay. It looks fine. Right? Right? Yes. And now in the end I need to find the result. Right? Recommendation from the yes, sure. If you have any recommendations, I'll use them. Okay, I find the result. Now I need to go back to the beginning. Can you wrap something in functions? Yes, you can wrap it in the functions. I believe it will not make a big difference here. Yes, you can do it like this. You can make some function which goes to here and update this. So here I obviously makes the same thing multiple times. But when you have like 8 times when you need to do something, if you do it carefully enough, usually it's fine. At some point, I will try to make some changes in this code, and then I will need to take care of to make the same change in all 6 positions. That will be bad, but if you just do it once, it's usually fine. Not the bad code, not the best code style again. Now I just need to find this result, right? Yeah, let's find the result. No, from n, right? From n, like here. So I take this p I a b c, and I need to ситуация по n где? Где? Тут есть. Где я потерял? Нет, я уже ответ устанавливаю. Я уже устанавливаю ответ. Now I need to decode this value. I hate this code. I hate this code so much. And now I need to put it into results. Oh no! If it's maximum, and I will increase it. So I need to say which variable was increased. But if I increased from maximum, it will not be increased. I hate this problem so much. I hate this problem so much. Okay, I can do it. I can do it. I know which variable was decreased. So when I know which variable was decreased. Ah, no. That's bullshit. I can just, no, I don't want to have frequencies. Can I spend another array? Can I do one more array? Can I do it like this? Okay, this code can be saved, so I will just embrace its ugliness. Yes, sometimes I write code like this. It's not the worst code in the planet, okay. Nice code. Reverse. I can't believe this code will pass the test. Okay, the hundreds lines of a great code. How can it fail? It cannot fail. Told you. Simple. Okay. Okay, let's read the tutorial again. What did they expect? Okay, let's see. At least one answer is no. Okay, if it is 1, whenever you see whatever two variables, at least one of them is 0. So the action for each step is uniquely different. Makes sense. If the sum is at least 2, if two variables modify and first one above 0, the answer is no. Otherwise, the answer is yes. In the latter case, you can always keep one of two variables modified for each term to be positive by the following strategy. If one of the variables that will be modified is 0 and the other is positive, then add one to the variable to 0 and subtract another. Makes sense. If it is 2, the variables that will be multiplied. And this is not the last term. and the string for this turn and the next turn differs, then add 1 to the variables that will be modified. So we need to only look for the current comment and the next comment, right? And we can always keep at least 2 variables non-negative. So we claim if the sum is at least 2, then we can keep 2 variables to be non-negative at any point. So every time you make a comment, you maintain the invariant that 2 variables are non-negative, and you can do it in all cases except this one, when you have 2 ones and 1, 1 and 0. If you have comment for these 2 variables, both ones, you make this comment, you have 2, 0, 0, and you need to make 2 in the position which will be used in the next comment. So you look up on the next comment, see which of these 2 variables will be used in the next comment, and make this variable 2, so it will become 1 on the next comment. That's actually clever. That's too clever. Okay. Sometimes the correct solution is clever, and you find some another solution. That's fine. This solution still works. It may be ugly, it may be overcomplicated, but it still works. Who's the editor? Let's see. I don't know these guys. Don't know these guys. Okay. Do we have enough time for another? Oh, we spent a whole hour for this contest. Let's have one more. The one used for coding. This is just C-line. This is just JetBrains C-line. Let's solve one more contest. Whew. So that was blue problem. Okay, we just overcomplicate things. Let's have one more. Show the members of web service register himself IDs to raise use another use. So it's hard to register user string contained by appending one character at the end of his ID. He's now trying to register the IDT. Determine whether this register specifies the property above. So we need to check if t is s plus 1 character. Okay, I can do it. So if let's look like this. Substr from 0 to s size equals to s. Okay, I'll go next. We have 8 cards. If the interpreter is similar, we have B cards with zeros and C cards with -1s. Okay, so we have some 1s, zeros, and -1s. We'll pick K among these cards. What is the maximum possible sum of the numbers written on the cards chosen? Okay. Qualitative sum. It's 208. We're now on 167. Okay, I'll solve it at some point. Not today, maybe. Let's do it like this simple way. I don't need this. So we eat all these numbers, then we eat all these numbers, then we eat all these numbers. Yeah, we still fit, right? Yeah. These numbers fit into right. Yeah. Задачки решаем. Очень интеллектуальный труд. Perhaps want to learn M algorithm initially. This understanding level M algorithm is 0. What happens? Visiting bookstore and books. Books sold. Yeah. Okay. They buy some read. He understands level. The understand level of G algorithm will increase by G for H. There is no other calculate for others. Okay. Objective is to make contain that levels of all algorithms X or higher. That is achievable. Find the minimal of 12. What? There are 12 books. We can iterate on all possible subsets, right? Okay. I just want to claim this problem isn't complete, but it isn't complete, but we have small values of n and m. Just need to check if X contains this bit. So if X contains bit I, then we take this book, right? So we increase this sum by the value of this book. And we'll increase the knowledge of each algorithm by the value of this book, right? Like this. So again, we just iterate over all possible subsets. For each subset, iterate of all books. If this book in our subset, we increase the sum by the cost of this book and increase the how it's called, level of knowledge, understanding level of each algorithm by this value. So in the end, we know the understanding level for each algorithm. Now we just check that everything is good. And if it is good, what we need to output this value. If it is impossible, -1. Like this. If s equals to int max, we output -1. That's all. Was at least x. X or higher. If it is less than x, then it's not good, right? Right. Oh. Nah. Nah. Okay, we lost another contest. That's sad. That's sad. What's wrong? Do you see the problem? NMX CAI, like this, okay. Max s equal to 0, bm, that's s plus equal. I, that's s, bj plus equal. Bj. Veltron looks fine. Не фартануло, понятно, ошибку найдите. If it's less than x equal to false, it could res min. Я не вижу, где ошибка-то. Давай, 3, 3, 10. So we have three books, three algorithms, and we need to make all levels at least 10. So if I by this 17 plus 50, it will be 10 here, 10 here, and 18 here. Looks fine. When is the next KD lesson? That's a good question. Good question. I don't know. When I have some more time, I will record another good lesson. But we actually recorded one more lesson. It's not by me, but by another lecturer, but it's not published yet. Because we need to prepare all the problems and stuff. I don't see the problem. Can you see the bug? It's about maximal flows. So that's what your job. I give lectures in ITMO. I have the whole channel about lectures in ITMO. No, running local testing is weak. We cannot do local testing. It's not fun. We need to find bug just by reading the code. Okay, I believe we can do it. My bad. So I used variable x here, and here I reused variable x, and CLion showed me that I have problem here, but I didn't trust him. Okay, let's save this. My bad. Okay. Sometimes you need to look on what actually your IDE suggests. So here IDE suggests you that you shouldn't make bitwise operations on signed integers. That's actually true, but actually you can. So it's not specified what's going on, but it actually in this compiler it is working. So I know I can do it. Here the same thing. I make bitwise operations on signed integers. You're not supposed to do it. Never do it in real code, but in Cotest it's fine because I know that in Constants I use the compiler, which works good with signed integers being used in the bitwise operations. How become a hacker? I'm not sure how to become a hacker. I'm not a hacker. I'm just solve some puzzles. I'm not a hacker. Do we have time before? Oh yes, we have half an hour before the football. Can the cache have 10 towns from the one teleporter in each town? Teleporter sends you to town AI. Okay. Hey, it's the king loves the positive integers, guys. The health is wonders what this town he'll be if he starts from and it's teleport exactly k times from there. Help king to write program which answers the question. Okay, that's simple. So we have n and k. K must be long. Who will build the Euro? England will, obviously. It's coming home. I just lived in London for a few weeks. I'm a big fan of London now. Okay, so it was very cool when they beat the Germany. So Italy is also good. Yes, I love Italy. Yes, but my heart is in England right now. So we just do it, okay? So now we read the input. Now we read the input. So what you can do? You can do it like this. So this is the current. This is our current position. While k greater than 0, we say x equal to a and x, like this. K minus minus. But it will not work, obviously, because k is big. Yeah. So what you can do is to skip the cycle. So if you see the cycle, you can skip the whole cycle. So how to find the cycle? We'll find the previous position when we have the same value. So we'll remember for each minus 1. So for each position, we'll remember the previous time we was in this position. So we'll say c of x equal to k. So we was here when k was equal to this. And now when we need to find the cycle, so if we already was here, we may find the length of the cycles. It's cx minus k. So this is the length of the cycle. Last time was here, it was cx, and now it is k. So this difference is the number of steps we need to make the full cycle. And now we need to skip the whole cycles until the length of the cycle is more than the current k. So we need to k minus equals sum t multiplied by L of cycle, right? Like this. So we skip some cycles in this build. We need to find the optimal value of this t. And this t should be such that this difference, so what I want to do, I want to find c such that k minus tl should be at more than 0, right? Now, if you write it like this, you move t to the right. So t multiplied by L should be less or equal than K. And now obviously t should be K divided by L. That's all. That's all. Okay, let's make it long. I believe that integer should be enough. What again? What's? Ah, yeah, it's actually, you're actually right. Let's make it then this long. На лид-коде не решаю. Не, я не знаю, что такое лид-код, кстати. Еще один какой-то такой сайт с задачками. Не знаю такое. So that's the whole plan. So again, without this, this part is just iterating over steps. So we're standing in position X. Each time we move to the next position, decrease the value of K. And this is optimization which skips the whole cycle. So if we see the whole cycle, we skip the cycle until the value of K is smaller than the length of the cycle. That's all. Yeah, that's all. Hate this. Runtime. Нет, я могу говорить по-русски легко. If it's easy for you to understand Russian, I can switch to Russian very easily. I hate this. I hate this. Так, еще. You never use uninitialized variables. For some reason, CLine didn't show you that you have problem here. So usually, CLine shows you that you have problem at some point, but for some reason it thinks that uninitialized variable is not a big problem. It is CLine again. This line, the site is @coder here, @coder beginner contest. Нечестно. Даже на примерах не работает, вообще не работает. Например, на примере. Опять оставим здесь. Раз, два, 3, 4, 5. Оказывается 4. Что оказывается plus 1? Ага. How can we meet you? Why do you want to meet me? Sounds scary. Что ж такое-то? Что не так я делаю сегодня? Она почти работает, но не везде. Да, вот тут я делаю не так. Here I want this k to be at least 1 after I'm doing so it's k minus 1. Because then I'm decreasing this k. So I want this k to be at least 1 after I do this operation. I forgot how to do it. I make too many bugs today. Okay, let's try to finish this. I have 20 minutes. And then let's paint these blocks and then consider the ways of painting the blocks different. The block paint different colors in this ways. Find the number of ways to paint the block and for condition for each block. Use one of the M colors, color 1 through color M to paint it. Not use all the maybe at most K percentages block painted the same colors. I hate combinatorics, you know. Two ways paint block different. So, нужно покрасить в M цветов. Должно быть не больше K пар одинакового цвета. Binary expansion type. Oh yes, that's also possible. Yes, you can. Yes. You can use instead of skipping these cycles, you can just use this binary binary, like how it called, binary lifting method, right? Yeah, you can do it totally. So I need to have at most K pairs. Same color. No idea. So each time I move to the next color, I may use the same color as previous, or I may use different color. So there is M minus 1 ways to use different color and 1 way to use the same color. Maybe we can subtract. So if you have So you have some colors. So each time you color this one, now you go here. There's m-1 way to color it to make them different, and one way to make the same color. Yeah. And we must have at most k pairs painted the same color. Basically, we're standing here, so this is number of pairs we have. Right here, 12 a.m. Oh, yeah. You may want to go sleep right now again. Maybe I need to start earlier with streams. So I'm standing here. I have m-1 ways to stand in the same place and one way to go here. And so on. And I need to have at most k positions like this. So basically I need to find the number of ways of length n. How to do it? I don't like this model. Is it a hint for FFT or not? If it is, I'm a little bit scared. I don't want to write the FFT today. Can I do it without FFT? Let's try to subtract. If you have all if you have all colors different, so if all pairs are different, then you have first of all you have m. For each next you have m-1. So if all pairs of neighbors are different, you have m multiplied by m-1 power n-9 variance, right? If all pairs are different. If one pair is the same, so if all pairs are different but one pair is the same, so here you have the same pair. So what does it mean? So you need to pick this position, right? So there is some binomial coefficient for this, and multiply it by this thing. So there is a number of ways you can pick these positions when you have these equal pairs, and you just multiply the number of variance by this binomial coefficient, and it will be the number of ways. I hate this problem. I hate this problem even more than the previous one. Okay, I will need to write all the model arithmetics again. Let's do it. So what's the plan? Let's read n, m, and k. Now what's the plan? I will so let's iterate a number of equal pairs from 0 to k. So I is the number of equal pairs. Now we need to pick where this equal pairs are in this line. So it's number of ways to choose I from n minus 1. Make it like this. And now I need to multiply this by m and by m in the power of, let's make my power. So I need to take m in the power of I plus 1, because I have first element, and each time I repeat the same element. No, when I repeat the same element, I have 1. Yes, I have 1, so it's just m. And then I multiply it by m minus 1 n minus I, like this, right? Colors cannot be the same. It can be the same, just neighbor colors are different. So each next color should be different from the previous one. So it's always m minus 1. Look fine. So that's the plan. Now we just need to add all these modular arithmetics to this, and we'll be fine. Let's go to add this modular arithmetics. Just a simple way. Yeah. Here I'm using bitwise arithmetic, and here I'm not. I don't know. What we count by I? The number of pairs of equal elements. So we have n minus 1 pairs, and some pairs are equal. So I is the number of these equal pairs. We should have at most k equal pairs. Recalculate. How can I pre-calculate it? I need to have different powers. Pre-calculate of I only use powers of this n minus 1. But I still need this binomial coefficient, so I still need some way to calculate these factorials and stuff. I already implemented it, so yeah. Multiple pairs of equal lengths. Yes, but the number of these pairs will be this. So this is number of ways to choose these pairs. So I have n minus 1 pairs. This is the number of different options how to choose these pairs. And now for each combination of these pairs, I have the same number of ways to choose the colors. So this is number of ways to choose the pairs, and this is number of ways to choose the colors. So number of ways to choose the colors doesn't depend on these pairs. So it doesn't matter where these pairs are. The number of colors should be the same. I already implemented this. Even if I don't need it, it's still be fine. N factorial like this. And not the clearest way. Not the clearest way to implement this. So this is the easiest way to calculate the inverse value if the number is prime. So if you calculate something modulo prime number, then you can calculate inverse value like this. Yeah. Have modulo here, modulo here, modulo here, modulo here. Let's check. I have modulo everywhere. I need to have modulo here and here. And here I will check if just to be sure. Because sometimes when you here I don't need it. I don't subtract anything. But sometimes when you subtract values modulo and calculated modulo, you may have negative value in the end just because how this modulo works in C++. So I usually do this in the end of each program when I calculate something modulo arithmetics. Looks fine. It looks fine. Football is starting. I hate it. I forgot some model somewhere or something like this. In the end, yep. And I checked this and I missed the football. Okay, let's find the final one. Let's make it quick. Bracket sequence. I love bracket sequence. Empty string concatenation. Yes, I know what is bracket sequence. Given n strings, can a bracket sequence be formed by concatenating n strings in same order? That's classical problem about bracket sequences. I use the same problems multiple times in different contexts. do I need to out? Yes or no? Okay, fine. The only thing you need to know about bracket sequence is the total balance and the minimal balance of this bracket sequence. So I'll have vector of pairs, integers, so B will be the current balance. So if Sj equal to open, I will increase B, else I will decrease B. And A will be the minimal balance in this bracket sequence. Now I'll just put this pair into. I have this. I hate this. I hate this. I hate this. Like this. So first element is the total balance of the bracket sequence, and second value is the minimal balance in this bracket sequence. And now I need to concatenate all these bracket sequences in some order. So what's the plan to do it? First, I will concatenate all bracket sequences which will increase my current balance. And you can do it by like this. So I will split it into two parts, positive and negative. Many of them. Okay, I have a lot of them. So if it is positive, so if this balance first is greater or equal, doesn't matter, then I add them into positive group. Pushback. And I want to sort this group by this minimal balance. Yeah. So I sort this group by the balance. So I want to add second, and then just for sorting. Здравствуйте. And if it is negative, I want to do the same but from the opposite side. So I want to add I want to add difference from here to here. It's total balance minus the minimal balance. And yeah, I will sort the. So again, what I'm doing next? Then first I add all the positive ones. So I add all the bracket sequences which we have positive balance. So I sort them by this minimal balance and add them in this order. You can do it greedily because each next sequence will be better if you increase the balance. Yes. So I sort them by this minimal balance and try to add them in this order. So if I can add this with this new bracket sequence, so if my current balance plus minimal balance of this bracket sequence is non-negative, then I can add this bracket sequence to my current state. So I will increase by this second and go to the next. I need a paper. I need paper to show this. I'm just rushed because the football is starting. Okay, so what's the plan again? So each bracket sequence is think like this. So if you have opening brackets, you go up. Yeah. If it's closed bracket, you go down. So each bracket sequence is basically the polyline like this. So if you have something like this, It's like here, you go up, up, then down, then up. Yeah. And the only thing you need to know about your bracket sequence is the total balance and the minimal balance. So you start from some point. So you go up, up, down, 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 up, down, down, up, down. If you want to combine these sequences into one big sequence, you only need to know this difference. So this is the balance. This is the total balance of your bracket sequence. And you want to know this point, because it is the minimal point and you can't go below 0. So you want to know this difference and you want to know this difference. Yeah. So these are two values you want to know for your bracket sequence. Let me put it to the left. Now, these are these two values of this B and C. So this value is B, this value is C. Now, when you what I want to do, I want to combine first all the positive sequences, so sequences which increases my current balance. So if my B is positive, I first add all sequences like this. So I start from point 0, add some point like this, then add something like this. So each time I increase my current balance. And I need to check then when I add new sequence, this minimal point is above 0. So I will sort these bracket sequences by increasing this minimal point. By increasing, by decreasing, because it's negative. Because it's negative. Yes, it's negative, so it's by decreasing, like this, like this. Yeah. So if this B is positive, I add the following pair. I add this minus C to sort them by increasing of the values. So first I add sequences with small minimal balance and then a bit big minimal balance. Okay. And then I will add all these sequences in this order greedily. And if it's possible, I will be able to do it. So if you add sequence by 1, 1, now if you look on this difference, let me show again. So you have two positive sequences. One positive sequence like this. Let's make and another positive sequence like this. Now you look at this value and you look at this value. This is how deep you go in the first bracket sequence, and this is how deep you go in the second bracket sequence. You can add these sequences by increasing of this value. Because if this value is big and this value is small, you can swap these two sequences and you have the same result. So you can do it greedily by increasing this value. So this is this value. Yeah. So again, second value is the minimal balance in this sequence. So if we have minus this, it will be exactly this difference. Yes, it will be exactly this difference. And now I add these sequences one by one in this order by increasing this value. And check if I can add the next sequence. So if I add the sequence, my minimal balance will be this. If this minimal balance is above 0, I can add this sequence and my new balance will be this. And if not, then I do something. Just say no. Yeah. You just say no. That's all. Now I added all the positive sequences. Now I need to add all the negative sequences. And you can add all negative sequences. You can do the same thing by just mirroring it like this horizontally. So you can do the same thing from right to left. And if you do from right to left, this thing is the difference between total balance and minimal balance. So it's exactly this difference. So first is total balance, second is the minimal balance. So this is the same value but from right to left. And when you add these negative sequences, you add them by decrease of this value. So again, just decreasing this value. Or you can do it in this, or we can do it. So let's just do the same thing for the negative sequences. Let's do minuses, just to make it absolutely the same. Now I will do the same thing from right to left for negative sequences. So the total picture will look like this. So first I have some positive sequences. Yeah. So each positive sequence have some minimal balance and then increase. Then have minimal balance and increase. So you have this positive sequence. So here I have these positive sequences. And now I add all negative sequences. They look like this. Yeah. So I will construct this ladder of positive sequences here in this code. And then I will construct this sequence of negative sequence here, just from right to left. And I do it in the same way. You just sort these negative sequences by this value. Again, this value is difference between total balance and the minimal balance. And yes, because we're going from right to left, this will be the change of the balance. So it's B2 negative B2. So we constructed this left part and this right part. And now we just check that B equal B2. Yeah, I believe that's all. Any more questions here? So, sorry, it was a little bit too quick, but I'm in a rush because of the football. Oh, no. I have some bug. Let's see. C is 0. Let's say if it's opening, I increase, it's decrease. So C is the minimal balance. B2 can be negative. No, B2 shouldn't be negative. B2 is the same thing, just constructed from right to left. So I just split this ladder into two parts. I construct this part from positive sequences, and I construct this part from negative sequences. I construct this part from left to right, and construct this part from right to left. And I want them to meet in the same point. So again, I add positive sequences by increasing of the minus AI second. AI second is this C. This C is the minimal balance of the sequence. Right. So it's the minimal balance of the sequence. So minus AI is this value. So it's this value. And I want to sort them by this value. Who's winning? You can give me news about football, just to keep me updated. Here I have the final balance. So it's the same thing from right to left, right? So I have I need this difference. This difference is the difference between final balance and the minimal balance. So it's AI first minus AI second. And the change of balance is minus AI first, because it's negative. I don't know, it looks fine. Should I read the problem again? Can a bracket sequence be formed by concatenating all n strings in some order? Yep. Here it is yes. So again, here if you look on so in this sample here, this is positive sequence, right? So this is positive sequence, this is negative sequence. We first add this positive sequence and then add this negative sequence. This positive sequence have balance 1 and this negative have balance -1. So added here, should be fine. What am I doing wrong? Did I miss something? Here. So we have two sequences with balance equal to 0. Here we have 0, here we have 0. So this B will be 0, but the minimal balance in this sequence is -1. And here it is 0. It's -1. So we will go here. Here we'll put -1. So it will be 1. I don't see any problem here. Що ж не так-то? We can work from here. Why not? Okay, J reserve. Here I can then flash the work, and here I can flash the work, okay. What can go wrong? So this last problem of hardcoder round 167. I don't get it. Looks fine. Did I miss something here? So have n and then n sequences, n, s. Minimum of this. Initialize this 0. Yes. BC. Total balance and minimal balance. If total balance is not negative. If total balance is not negative, I added two positives with minus second and a first. I don't know, it looks totally fine. What's the problem? Yeah, this is the classic problem. And I have some bug. No idea. So it's not working on the second sample and fourth sample. Even here I say yes. What? Here. Because I need this value, I need the difference from the total balance and the minimal balance. So it's like the same thing from when you look from right to left. So let me show. So when you go from right to left, you need to sort them by this difference, and this difference is the difference between total balance and the minimal balance. So this is your bracket sequence, this is the total balance, this is the minimal balance. You want to sort by this value. Okay, we're already lost, so let's try to take a local testing. Local testing is for the weak. Yep. I say yes. Why I say yes? Because I'm stupid. Let's check what's going on here. So I have two positive sequences, 1 0 0 and another 0 0. What? Why it is 0 0? Why size of A is 4? What? Ah, because I'm an idiot. Oh, that totally explains everything. That explains everything, because I cannot read the data. Because here I'm creating an array of size n, and then I push another n values. Okay. Makes sense. If you can't read the data correctly, you will not get a good result. Okay, enough for today. Okay, maybe see you some other days in this week. Maybe tomorrow, maybe on Friday, I'm not sure. So, see you soon.